Hi, everybody. This is Bill Bittner. We're back here at the VM workshop in 2020. Our next presentation is by a longtime fan and contributor to the VM workshop, Rich Smrcina, and he's going to cover some monitoring zVSE with zVPS. Rich, over to you.
Thank you very much, Bill. I'm glad everybody could hang out. And who is Velocity Software? We were founded in 1988, and the mission being to provide, to assist customers with optimizing their ZVM platform through a set of products, a product suite, I should say, that provides that service. Continuously integrated with enhancements for over 30 years now, ever since we started. We have well over 200 installations of zVPS, more than half the IFLs worldwide, 22 countries, 6 continents, and I'm sure that at some point, if a mainframe gets installed in Antarctica, we will be on it at some point in time. Headquartered in Mountain View, California, with offices in various places in the United States and also in Germany. zVSE introduced SNMP at the 4.3, zVSE 4.3 release level. Since we use SNMP to monitor Linux, it was a very natural progression just to use SNMP on VSE to get data from VSE as well. We introduced zVSE monitoring in about 2010 based on the plugins that were provided by IBM with the SNMP package. We added our own partition plugin in 2014, which displays a partition and a job information as those jobs are running. Now we fast forward to 2020, there's a renewed interest in zVSE monitoring, not only from us, but customers, which certainly primarily drive what we do. And based on our recent dive into ZOS monitoring, that infrastructure that we set up on ZOS provides the ability to do some very similar things on VSE in addition to SNMP. So here's where we introduced a product called VSEMON. It provides updated partition monitoring. And by that, I mean, instead of making 17 requests from SNMP to get data for a single partition, we make one request per partition. So it's much faster, much less overhead. And we're also providing CICS monitoring, which is the very similar to how it's done on ZOS. I'm going to talk about that in a little bit. And we're also providing TCP/IP stack monitoring. So with the updated partition monitoring, step and job ends are more closely tracked. And I indicated the performance improvements over the previous plugin we had. And this display that I'm showing is a look at what the partitions might look like for a specific VSE system. You see the totals on the top of the display and each partition listed. And over the third or fourth to end column, you see that stop time column indicates when the previous step ended in that job, or if it was the job end, if the job ended itself, along with the return code and cancel code. We do rely on DMF to provide the CICS data. That's the record type 110, very similar to SNF on ZOS. Velocity provides a exit that runs in the DMF partition that intercepts the data that's written out to the DMF data sets and routes that over to ZVM. All of the processing is performed on the VM side using cheap IFL resources, preserving that precious general processor CPU time for work that really needs to get done. In this DMF exit, customers have the option to bypass writing the DMF data so that if you don't need to retain that data for any other processing on VSE, you have the option to do so. This display right here shows 3 different VSE systems. You can see that the node name is the VSE system name. And I'm highlighting the fact that the DMF, the DMF partition itself is only using 0.2% of the CPU resources. And under that, those are the first line. It says 61B equals 6.8, 62B equals 10.7, etc. Those are the transaction rates that were in effect at the time that I took the screenshot. So the sustained total of transactions would be about 650,000 to 700,000 a day for those 3 VSE systems. So the overhead of doing this DMF processing is very low. Bill, I can't see the chat for some reason, so if anything comes up, feel free to interrupt me, please. We also provide TCP/IP monitoring. There's a plugin, a specific plugin for each TCP/IP stack, both the IP6 for VSE and TCP/IP for VSE. The IP6 for VSE from Bernard Software, that is currently available. The data maps directly into fields that are already available in zVPS, those that we use for network monitoring from Linux. TCP/IP for VSE research is ongoing, and we have a statement of direction to provide that support. This display underneath shows a little bit of information that we get out of the plugin for IP6 for VSE from Bernard Software. And I suspect that we would get similar information for the CSI stack. So here are the requirements. For system and partition data, we're fine with zVSE 5.1 and above. Since version 5 and actually 6.1 is now is out of support, we're only doing testing for new features on version 6. So for CSES and TCP/IP data, we are going to require a 6.1 zVSE 6.1 and above. 6.2 is the only release that's currently supported. It may work on version 5. We're just not going to be testing version 5. The VSE supplied SNMP agent with our plugins is also required. It's delivered with zVSE. BSI stack must be at 258 pre-24 or higher. And the CSI stack has additional requirements in addition to the C server, which is delivered with TCP/IP for VSE. The VSE README will have updated requirements, so that should be the definitive reference instead of this slide. For CICS, DMF must be running. We do suggest that you set it to a 1-minute interval because the rest of the product suite is lined up to a 1-minute interval. So all of the displays, all of the history, that's all. We rely on that 1-minute interval throughout the product. So we suggest that. And CICS performance and statistics should be turned on, additionally set to a 1-minute interval. VSEMON is provided as a zVPS installation package. For those that are familiar with zVPS, we provide VMF PLCD archives, and VSEMON is no different. When it's installed, we have a top-level directory is created, and something called a BJB file is put there. Those familiar with VSE software delivery, BJB is basically a binary job, and you transfer it to VSE, respond to the prompt, which is basically where you want to install the code. Samples are also added to the top-level directory for the excuse me, for the SNMP server, the SNMP configuration, and VSI DMF config, which is it's a little configuration member that that DMF exit uses to configure itself. And a number of other items are cataloged and linked. The plugin phases. There's a CSES PLT PI phase that we suggest using for VSE shops. Basically what it does is it resets the monitor excuse me, and make sure statistics turned on. And it does this at midnight. The VSI DMF exit phase itself, which is something that you will run in the DMF partition. I have an example of that later. And a REX program that is used to delay the DMF startup. The reason we do that is so that we get the DMF data as close to the top of the minute as we can, so that we can honor that that minute granularity that we need. As the plugin implementation is, this is the SNMP configuration member that gets stored in the library. These two plugins here on the bottom, those are our, the SNMPP plugin is the partition plugin, and the BSTCP, that's for Bernard Software's TCP IP stack. If you are going to be using the CSI stack, there will be a plugin for that as well. And when you start up SNMP, you will see information about those plugins as they start up, giving you the version number, etc. For CICS, these DFH SIT updates should be in place to turn on monitoring, set on certain monitoring configuration items, in addition to turning on statistics. And the DFH PLT PI program will get also needs an update in the PLT table. To check statistics, very simple, is just use the CEMT transaction to inquire statistics, make sure statistics is on, and set to a 1 minute interval. And there's some CEDA definition snippets there for the defining the PLT PI program and its associated transaction. In the DMF startup, we suggest that you put the phase where the REX program is, where the, not with the REX program, where the DMF exit is cataloged before the SDL, so that we get loaded before any other VSAM exits, and then add that startup delay before the DMF startup. The DMF configuration, pretty standard out of the box, except for specifying the interval, set the interval to 1 minute, set the data space size for the DMF data to 16 megabytes. That is suggested by CSCS support, actually. And the system identifier. Setting a unique system identifier is very important, because if they're all set the same, you won't be able to differentiate between the different VSE systems. So making this unique is very important. Unique for each VSE system, I should say. As far as navigation goes, this is our main menu in our web interface called the zView, and there is a zVSE menu that you can click on, and you can see those 5 entries underneath it. What I don't show here is that you can mouse over any one of those entries to actually see the title of the screen that would come up once you click one of those entries. So here's the first screen, VSES, system configuration. This is basically just configuration information about the VSE machines. What the virtual virtual machine name is. I'll get the words out. Logical partition name, number of partitions, priorities, etc. Next is a couple of performance screens. Now these screens have very similar data, the big difference being the one on the bottom. If you're running multiple virtual CPUs or multiple, in an LPAR, multiple CPUs, you will be able to see each individual CPU on that bottom screen. Otherwise, the information is very similar. For any of the screens, whether they're VSE screens, ZOS screens, VM, Linux, whatever the case is, we can always go back in time to look at data from previous time periods. And that is accomplished by this little pencil icon in the upper right corner of each screen. If you click on the little pencil, you'll get this parameters box where you can fill in different time frames to look back in history. And also in this case, a specific node name. The node name is a VSE machine. So what I've done is I've entered that information, click the submit button on the bottom left, and the result is the tall screen on the far right, where I can see exactly from 3 o'clock through 4 o'clock, the CPU utilization is about the 5th or 6th column in, and you can see whatever data you want for whatever time frame you want. This is what the partition display looks like. Now, this is 3 different VSE machines, and you notice that some of these partitions, especially down here in this 61C machine, indicates that there's multiple job steps. What that provides for is the ability to show multiple steps that have run within a 1-minute interval. At this point, it's summarized, but if I click on one of those, I can see the multiple job steps that show up in this case, this Y2 partition. And if we look on the right-hand side under the stop time, you'll see that the steps started and stopped within this 1-minute interval. And this third step, the one that's on the top one in the green there, it's still running in this interval. We also provide a lot of graphical data. And in this case, this shows 4 VSE machines over a period of about 30 minutes. And what I'm highlighted here is there's a point on the graph on the right-hand side that I actually moused over. And what you can see is the actual time that that point occurred. That's very helpful for a more dense graph, and the value that went into generating that point, that data point. If I click on that, we have a drill down capability. And what that drill down provides for is at that point in time, this shows us the actual partitions that were, or the actual jobs that were running in the various partitions. Excuse me. And you can see this STG play job accounted for a good deal of the CPU at that point in time. And just like with the tabular screens, the graphical screens also provide the ability to go back in time. So I did the exact same thing here on this 62B machine, going from 3 o'clock to 4 o'clock, and we can see a lot of different peaks that have occurred during that time frame. Now we have something in zView called the Enterprise View. It provides the ability to see a number of different VM systems on one pane of glass. This excuse me, this VM2 machine that is highlighted here is just one of the VM systems that we have in our infrastructure. And it is showing a number of VSE machines. So we can see the VSE systems on that display, along with any Linux machines, any distributed Linux machines. And clicking on any one of those VSE machines will provide you with something, will bring up something called the My VSE view. And what that shows us is that gives us a number of different tables and this specific graph for that VSE machine at that specific time. So this is a good glance at what VSE is doing at the moment. You can also load My VSE, the My VSE view, I should say, explicitly to be able to see all the VSE machines. So this is what My VSE might look like with all the VSE machines listed. And as with any other display, the tab also has a parameter selection mechanism. So if I click on the pencil for the tab, you see where the arrow is pointing there, I get a very elaborate selection mechanism where I can go back in time, pick specific nodes. A VSE would be a node in this case, to see VSE machines. So this would control all of the screens in a tab, I should say. For TCP/IP data, we have a number of different displays that show TCP/IP information. I'm not going to get into a lot of detail about this, except for the screen on the bottom here, this TCP4, which shows us inputs and outputs in addition to the different interfaces. So there's one VSE machine here on the bottom that has 2 interfaces, but only one of them is actually active. We also provide a network activity graph that will show us input and output activity for VSE machines. On to CICS data. CICS has a menu selection entry as well, in addition to VSE. Now, don't be all freaked out because all the reports start with ZOS. The displays are essentially the same. There are some things that don't apply to VSE, obviously, but the displays are essentially the same. So if we look at this first report on the upper right here, the CICS1, this gives us kind of an overview of what CICS is doing, when it started, what the Apple ID is, what the job name is, where it's running, what the release is, and some transaction display information. The next display here, the CICS2, gives us a little more detail, more specifically about dispatch delays. So this dispatch delays section, which is off to the right, gives us an idea of what is causing CICS transactions to wait. This next display is a more detailed analysis of CICS transactions. So this actually tells us how many of specific transactions, tran IDs, have been have run in this interval. You can see the count along with response time, suspend time. These fields on the right, basically the right half of the display, covers the vast majority, or actually it covers all of the IO wait type fields. So anything from this TRN column on out are associated with IO wait for CICS transactions. This next display shows some of the graphs that are available. Transaction rate on the upper left, response time on the upper right, CPU time on the bottom left, and max task percentage on the bottom right. Max task is a very bad situation to get into, so I wanted to make sure that that we were able to show that in graphical form, so that you can all on any of these graphs. Of course, you can go back in time to look at the data. Some additional graphs, CICS delay analysis. Remember that on one of those screens I mentioned the CICS the dispatch delays. Well, this is the dispatch delays on graphical form, so we can see exactly for which regions, for which CICS regions running on whatever system it is, we can see exactly what the dispatch delays are. And again, on the upper right, the response time. What I'm trying to show here is from the response time from any of these screens, actually, you can do drill down. So from response time on the upper right, I clicked one of the CICS regions and got the graph on the bottom left. So from response time for all the regions, I went to, on the bottom left, response time for a specific region. So I can see exactly how response time has been changing by default here over 30 minutes, but of course you can change the times if you want by clicking on the little pencil in the graph. And on the bottom left, what I did is I clicked on a specific time frame and got a display of all of the transactions that ran in that specific time frame in that region. So what I can glean from this graph is this ZipR transaction, if I'm reading the colors correctly, was the source for increased response time for that CICS region. And of course, as with any of the displays, you can go back in time. So if I want to see the response time over a period of time, I can certainly do that by entering in the time values and any other selection criteria that that I want to narrow down the display. We also provide a number of views, which are default displays that encompass a number of different graphs or textual displays. This is one of the views that we provide, which gives you an idea of, shows a lot of the information about various CICS regions. Here's another view that goes and shows the transaction detail along with response time and CPU time. And yet a third view that shows a lot of the shows the dispatch delays in tabular form, and in the bottom left shows them in graphical form. Now these views come with the product, but you certainly don't have to use them the way they are. If you can certainly change the views if you want to see different information. We will not overlay those views in subsequent product delivery. But they're there as a starting point if you want to use them. We also have an alert mechanism that is available with the product suite. It is a component that comes with zVPS. It provides the ability to look at 1-minute data based on customer rules. So these are rules that the customer defines of things to look at that are important to them. We provide a lot of examples. There are a number of them shipped with the product, with the Z-Alert product, and there's a bunch more up on the website. But what I did here is I'm checking for return codes for from job execution. So you can see this job in the green screen display. It ended with a return code 8, and certainly this message popped up on the system console. I captured this from our Z operator component, which provides an operator display for ZVM systems. And you could take action on any of these alerts. So if a certain job cancels, we could notify the application owners that a job is canceled, and that could be either done from Z-Alert itself or based on Z operator. If you have Z operator installed, Z operator can send out those notifications. That can be email, that can be an SNMP trap, that can be a message to their CMS machine, whatever the case is. Real-time data is always displayed in 1-minute intervals. At the end of the day, there's a process that starts up, it's called ZMAP, that takes all that real-time data, all that 1-minute data, and summarizes it into 15-minute intervals. And that provides a couple of different things. That provides for a bunch of reports that we generate based on that summarization, but it also puts that data into a long-term database. And that long-term database is a source for capacity planning purposes. These reports certainly cover ZVM and Linux, and of course ZVSE. And if you look at these reports, on the left is the menu item. If we ZMAP, this is ZMAP tab in the green on the upper left. It is where all the reports are. And if I scroll down in the report list, I see the VSE reports in the list. The reports are mirror almost exactly what the screens look like. Excuse me. So the formats are going to be extremely similar, if not exact.
So Rich, we have a question here in the chat.
Yep, go ahead. I'm almost done actually, but go ahead.
All right. Based on the use of SNMP plugin and the 1 minute interval, the most delay from the time an issue occurs and the time an alert is generated is roughly 1 minute. Is that correct?
Roughly, yes.
Okay. Thank you.
Okay. A couple of different reports, additional reports here for the partition display. Actually, two different reports. One partition display up on top and the completed job report. So the idea here is with the bottom report is this is probably more of a job accounting kind of thing where you can see all the completed jobs for the day. And we do have an extract language where we can extract the data, the long-term data or the short-term data, whatever the case is, so that you can generate your own reports or your own data files, or even export the data somewhere to be used with other tools. We are the recognized leader for performance for ZVM, ZVSE, and Linux. We've recently added the collection of ZOS to our portfolio, so if that is of interest to you, you can certainly let us know. Performance monitoring should not be the performance problem. So the idea here is you don't want to have to turn off the performance monitor because you're having a performance problem. If anything, that is the exact time when you need your performance monitor. So we strive to be very lightweight, very low latency, and a good customer, as it were, for you to help you analyze any performance problems. We certainly listen to customers and strive to provide any updates or functions that are required by our customers. Don't hesitate to reach out. You can send us requests to info@velocitysoftware.com. And with that, I am done.
So Rich, we had one more question here in the chat.
Yep.
What can you tell us about support for gathering and reporting GetViz data from VSE?
We understand that is a requirement. That is certainly not the first time we've heard it, and we are certainly looking into that. I can tell you that much. I can't tell you delivery at this point, but we can certainly we're certainly looking into that.
Okay. And another question just in. What type of information do you show for the TCP/IP stacks?
That was actually way back here. Give me a minute here to get back. We show network activity information. So this screen right here. So this gives us an idea of there's four different screens here that I put up on this one display. And it actually shows two different VSE machines, this 6.1b and 6.2b. Communications segments transmitted, UDP datagrams, IP datagrams, any errors that come out that the stack reports will report here. And then on the bottom here, this hardware layer display that shows us data going in and out of the actual interfaces. Does that answer the question?
I believe so. Any other questions for Rich? Feel free to unmute yourself and ask them or put them in the chat.
Hey, Rich, Ken Ripple.
Hey, Ken.
Hey, how are you?
I'm very well, thanks.
Any plans for statistics on Telnet server partitions or servers, depending on whether it's BSI or CSI, in terms of the number of sessions and stats like that? Because, running out of sessions in a Telnet server impacts the business.
We have not looked into that, but that is a good question. I'll take that back to development.
should be something gatherable through stat commands on either stack.
Yes, actually, I believe BSI provides that in SMF data or DMF data, and CSI provides not specific telnet session counts, I don't think, but they provide that in their control block of all of this big control block of data that we get out of the C server.
Okay. Just a question.
So that's more related to TCP/IP application type reporting is basically what you're looking into, specifically in this case, Telnet.
Yes.
Yep. All right.
Thank you.
Yep.
Okay. Other questions? All right. Well, then I thank you very much, Rich. I know you'll be around for a while. Also, I should probably point out and thank, for those that aren't aware, Rich, amongst many things, is also the webmaster for the VM workshop that's hosted on Velocity. So we appreciate that. Thanks again, Rich. Great job.
Thank you, Bill. Thanks, everybody. Have a good afternoon.